Have you ever wondered how or why things make sounds? Sound comes so naturally to us from our very first year of life, but many of us don't stop to think about what it really is. It turns out that sound is a wave, but what exactly is a wave? A wave is a vibration in space and time. The material vibrates up and down over a period of time. A sound is a specific type of wave that takes the form of vibrations traveling through air, water, or any other material. From a human perspective, sound is distinctive because of the way we perceive it. Sound is detected by our eardrums. When a sound passes through the air in the form of vibrations, those vibrations eventually make their way to our ears. When they do that, they cause our eardrums to vibrate, which sends electrical signals to the human brain. Our brains perceive these electrical signals as sounds. But it's a bit more complicated than that, because no two sounds are the same. A sound can be quiet, or it can be loud. A sound can be high-pitched, like a squeaky voice, or it can be low-pitched and booming, like a foghorn. So what, other than our perception, decides what a sound will be like? There are many factors that affect sound. The most important ones are frequency, or pitch, and volume. The shape of the wave decides these features. Frequency is how high or low a given sound is. A high-pitch or high-frequency sound is like a high note on a piano. A low-pitch or low-frequency sound is like a bass drum or rumble. And then there's everything in between. Frequency is measured in hertz. For example, the A note above middle C is defined as 440 hertz. In waveform, a high-frequency sound is one where there are many waves each second. A low-frequency sound is the opposite, where there are very few waves that pass by each second. Here's what different frequencies of a wave look like. And then there's volume. A high-volume sound wave is one we perceive as being loud, like an airplane. A low-volume sound wave is perceived as quiet, like a rustling of leaves. When it comes to the wave itself, a high-volume wave has a high amplitude. The amplitude is the height of the wave from the rest position. Here, for example, is a low-volume and high-volume wave. So, if it's all about frequency and amplitude, pitch and loudness, why does a violin sound different than a flute? Well, that's a matter of timbre, or the quality of sound. The truth is that real sound waves are complex with lots of little sounds layered on top of each other. The exact way these sounds are layered is the timbre. Remember, all of these features as we perceive them are really just the way our brains interpret the sound. In the physical world, sound is simply a matter of how many waves pass per second and how big the wave is from top to bottom. All right, let's take a few moments to review what we've learned. A wave is a vibration in space and time, while a sound is a specific type of wave that takes the form of vibrations traveling through air, water, or any other material. We detect sound waves when the vibration passes into our ears, causing our eardrums to vibrate. Sound is how we interpret that in our brains. We have many ways of interpreting sound. A sound may seem loud or quiet. The volume of a sound is determined by the wave's amplitude, which is how high the wave gets above the midline. A sound might also seem high-pitched, like a squeak, or low-pitched, like a rumble. The pitch of a sound is determined by its frequency, which is how many waves pass by each second. If waves pass by quickly, that's a high-frequency or high-pitched sound. And if waves pass by slowly, that's a low-frequency, low-pitched sound. Everything we hear is just our brain's interpretation, but sounds are really just features of the wave.